Alright, today we're going to continue talking about standard form. We've brought this up in some other lectures before, but as a reminder, a standard form of a linear equation is ax plus by equals c. A, b, and c are real numbers, and a and b cannot both be 0. Remember, there's no fractions in standard form, and a must be positive. Well, really what we're going to be doing today is graphing the equations. We're going to use the most appropriate method. So we've learned different ways of graphing. Those being t-charts, we can use x and y intercepts, and we can use slope-intercept form. So we're just going to talk about when and what is the most appropriate method. You can always use a t-chart, no matter whatever type of equation you have. This problem, the two best methods would be using a t-chart or using slope-intercept form. I'm going to use slope-intercept form because it's faster than using a t-chart. So here is my m, and here is my b. Remember that slope, if it's negative 2/5, is either negative 2 over positive 5, or you could do positive 2 over negative 5. Either one of those is correct. You can't make them both negative, otherwise it becomes positive. Also, remember that you need to be graphing this first. So graph this first. So when you graph on the y-axis, the y-intercept is 1. From there, you're going to go down 2 to the right 5. Or you could go, using the second fraction, up to rise to the left 5. Remember, our slope is rise over run. So you go up or down, and then left or right. Notice how the graph does have a negative slope, so I can feel secure that I've done this negative slope appropriately. The second example I have here, we're talking about the most appropriate method. I would not say that slope-intercept form is the most appropriate method or a t-chart necessarily, because t-charts work really well when we have a y equals equation. You could use a t-chart on this, but we'd have to solve for y. We could use slope-intercept form, but we'd have to solve for y on both of those. So in my opinion, the most appropriate way to graph this would be using x and y intercepts. So we haven't done that in a little while. Let's remind what an x-intercept is and what a y-intercept is. We've been seeing lots of y-intercepts. X-intercepts is where it crosses the x-axis, and y-intercept where it crosses the y-axis. So along the x-axis, we have the points 1, 0, 2, 0, 3, 0, 4, 0. Y is always 0. So for the x-intercept, we'll be keeping the x portion and putting 0 in for y. When I do that, I get 0 here, so I get 2x equals negative 18. Divide by 2 on both sides, and I get negative 9. So my x-intercept is negative 9. Let's go ahead and do the y-intercept in blue here. The y-intercept is where it crosses the y-axis. That's all along the y-axis is 0, 1, 0, 2, 0, 3, 0, 4. So you keep hearing the 0. That's the x portion. So we're going to put 0 in for x and solve for y. Now this creates 0. So you have a negative 3y is equal to negative 18. Divide by negative 3, and you get y as positive 6. So we're going to plot the 6, connect our two dots, and I missed that one a bit, so I'll make it a little bit bigger. And there's our line. This next one, the most appropriate method would be using just slope-intercept form. So my slope is negative 2. My b value is 0. I can use the slope as being negative 2 over 1, or I can do 2 over negative 1. So I'm going to plot this part first. So your b value first. B is 0. My rise is negative 2, so I'm going to fall 2, go to the right 1. I can do that a couple times. Fall 2, go to the right 1. Notice how that creates negative slope. Or I could rise 2, up 2 to the left 1. Up 2 to the left 1. This does create a line. You can do that as many times as you would like. I can feel secure in my answer because I have a negative slope, and that is what my slope looks like in my picture.